Welcome to the Decoding Innovation podcast series, brought to you by the EY Nottingham Spurk Innovation Hub, where we explore the innovative technologies, business models, and ideas that are shaping the future of industries. During each episode, Mitali Sharma, a principal in the EY Parthenon strategy practice, meets with stakeholders at the cutting edge to discuss innovations in their space, challenges they need to overcome, and their outlook on the future.
I'm your host, Mitali Sharma, and today's topic is circular economy. Our guest is Felix Heisel, the Assistant Professor and Director of Circular Construction Lab at the Cornell University. The lab houses a design research program that is working on moving us away from linear material consumption within the construction industry. Welcome to the show, Felix.
Thank you for having us.
Felix, let's start with your background. As the director of the Circular Construction Lab, what do you oversee? And of course, feel free to add your journey so far.
Yeah, I'm happy to answer that. So I have an office in Germany, and now I'm researching and teaching here in the US at Cornell University. And the Circular Construction Lab is essentially a research unit that I founded 2.5 years ago when I arrived here at Cornell University to answer some of those critical questions that we notice both in practice and in teaching. And so that unit sort of tries to bridge that gap and find technical and methodological solutions to how can we scale reuse in the built environment, and how can we bring circular economy thinking and circular business models and policy questions and all the kind of the bigger scope that is necessary to scale reuse into the conversation in connection with the kind of architectural design and the everyday questions that we also need to address in this conversation.
Thank you. And if we can start with the basics, Felix, what does circular economy actually mean for you? Because the word can mean different things for different people. And also, what does it mean in the construction industry?
Yeah, that's a super important question. And you're right, there is no officially defined definition of a circular economy yet. We usually go back to a definition that the Ellen MacArthur Foundation published in 2015, which is a regenerative system by design that is keeping products, components, and materials at their highest utility and value at all times, and separates biological and technical metabolisms. So that's the definition that we're working off right now, although this is constantly expanding into different directions because that definition is granted a very kind of material-based and stock and flow-based definition, and the circular economy, of course, encompasses much more than that to make it work.
Within the construction industry, what does that mean?
That then is kind of the most important aspect, essentially, because if you look at what is happening right now and what the construction industry's role is in the many kind of today's crises that we have, maybe picking just on one, the climate crisis, then the linear construction industry is responsible for, in my opinion, probably more than 40% of carbon emissions globally. But apart from that, we're also producing the majority of waste, and we're responsible for scraping the Earth's crust for new virgin resources. And also there, the majority of these resources goes into the built environment. And so over the whole life cycle of buildings, we're responsible for more than 50% of resources that are being mined every day. And on the other side of that linear timeline, also between 40 and 50% of waste. And so that is unsustainable in the least, right? And the idea of now trying to connect the beginning and the end of that timeline and working in closed loops, so within a circular economy, is one way and a very promising suggestion and method to change the role that the built environment has in these global crises today.
That's interesting. So do you think of all materials within construction as equal, or is there a hierarchy in your opinion?
I would phrase it differently. I would say that all materials have to be in a circular economy, but the methods and tools that we are using can vary wildly between what type of material and what type of application we're having. We tend to go back to Stuart Brand's diagram of shearing layers, which essentially separates a building into 7 different layers. For an example, you could say the structure is one layer, the facade or the shell is another one, and all the stuff that people use, for example, furniture, is another one of these layers. And the importance of that separation is that the service time of each of these layers is extremely different, right? So you can have on the furniture level, a furniture arrangement might last 3-4 days, and then you move that chair. You might actually only move it after an hour, right? Or while you're sitting on it. Versus the structure of a building ideally lasts for centuries. And so the timelines of these different layers is very different, which means the strategies that we need to close these loops are also very different, because we can have, for example, a leasing model for carpets, for light, for furniture, but it is extremely difficult to implement a leasing model for a structure where a company would have to say, well, you can return that structure to me in 100 years. And granted, who knows what happens to that company within the next 100 years and what that relationship is. And so the strategies, the circular strategies that we apply vary between these different layers and these different applications. But the goal should always be to make sure that every material in a building can be and will be used in a circular economy.
Anybody who's been a student can totally relate to recycling furniture. But tell us a little bit more about the other layers. I'd love to hear that.
There's 2 aspects of it. The one aspect that we're working on is how do you understand the current built environment as a resource? And how can we activate all the materials that have been used already, all the walls, the surfaces, the structure, everything that we have around us right now, as a resource for a future building, so for a next generation. And that requires new technologies and new techniques of accessing these materials. The keyword being urban mining. And urban mining is a very interesting and I think very fitting title for this, because mining in itself is a rather dirty process, unfortunately, right? You tend to have byproducts, tend to have contaminants that need to be taken out to then in the end have that raw material that you're interested in. And it's the same with the urban environment right now, because none of the buildings that we're living in right now, or a very, very large majority of the buildings that we're living in right now or working in right now, have been designed for circularity. They have been designed with eternity in mind. We're building them, they're going to be there. And the end of service wasn't part of that design thinking. So now when we go in and reactivate these materials, we're dealing with the problems that we need to mine these materials. So we need to cut out a beam because we can't separate the connection. We need to rip apart things that have been glued together in a way that we can't separate them. And so we will have losses, we will have byproducts, we will have contaminants. Talk about asbestos, lead, and all the other materials that we've used in the past that are still part of our built environment. And so a percentage can be reintegrated, but we need new technologies and techniques to do that. And so that's one part of that question that you asked. The other part is, what do we do differently from now on? And that keyword is design for disassembly or design for adaptability, where we now, when we design a new building, already take into consideration that after a certain time, that building will be disassembled. So all the connections, all the details, everything that is part of that design process and the making of a building is already geared towards a closing of loops, which means there are no irreversible connections in a building, ideally, that we construct today. There are already separations between these shearing layers that I mentioned earlier. There are new business models, new techniques integrated to keep utility and value of products at their highest level, et cetera, et cetera. So ideally, the best case scenario is that we use materials from the urban mine to design a new building that is intended for reuse, right? And so that would be a shift towards a completely new paradigm in construction.
So I want to go towards the future in a little bit, but I want to unpack some of the earlier statements that you made. And just to make it real for me. So for example, in a building, glass is used, wood is used, concrete is used, and other such materials. How do you think about each of those materials differently? You said each of them, needs a different sort of paradigm or way of thinking. So if you could sort of elaborate on that, that would be great.
Yeah, it's super important to separate those because the technical requirements, the specifications of each material are very different. The recyclability is different, the reusability is different, and also those are two very important different conversations. And so if we zoom into some of the materials that you just mentioned, for example, if you look at glass is technically 100% recyclable, right? You can reheat it and make new glass out of it. The problem there is that a tiny amount of contamination doesn't already is enough to basically lead to a downcycling. What I'm trying to say is that if we have a high performance glass that is a float glass that comes out of the factory, as long as we recycle basically cutoffs in that factory, we're good. But now taking a glass out of a building and bringing that back into that factory, from what we've researched, the level of contamination that is already too much is 1 gram in a ton of material. So basically, if there's a corn of dust in that glass, that float glass process doesn't work anymore because it's going to lead to cracks or bubbles in that pristine high performance surface. And so the way our construction industry works right now simply doesn't allow that level of control to close the loop. And so most of the float glass that we're taking out, if it's recycled, goes into bottle or container glass, where these contaminant limits are much higher and much easier to fulfill. And so we're making bottles out of them, which is circular, but it's not kind of fulfilling the requirement of a circular economy that says at their highest utility and value. Because we're downcycling, right? And so the question then, to stick with the example of glass, would be, how do we do this differently? And that's where reuse comes into place. If recycling doesn't work, then and it's always better to reuse. The smaller the cycle, that's another thing in the circular economy, the smaller the cycle, the better. So you first want to reuse, and you want to ideally reuse locally, because then you don't have emissions from transport that are added into the conversation, for example, right? And so you can certainly reuse glass, but the problems there are that over the last years, requirements and policies and codes have changed. And so a glass from 100 years ago is way too thin, and the U value or R value is too little. And so we need new design strategies to integrate these windows if we were to use them as windows again. And there are wonderful examples where you, for example, use 2 old windows and make a kind of replace them one after the other. And so by that, essentially create a double pane window out of 2 existing windows. And have that kind of beautiful aesthetic as well that comes with these overlapping layers in your structure, but that might not apply everywhere. And so ideally, the way we design a new window today is that we take that reuse component into consideration already in the making and the production of that window, make sure that we can safely and easily take that window out, maybe have companies that have leasing systems or that have take-back systems that make sure that these quality controls that are necessary for these processes are fulfilled, so that we can really fulfill the requirements of the circular economy. And that's just the example of glass, right? In timber, for example, we have a very different conversation because we're then not in a technical metabolism, but in a biological metabolism, where in theory, the form doesn't matter that much because we can compost a product. And so out of a timber beam can become a rice corn, can become a biofuel, et cetera, et cetera. So the cycle is a much, much bigger metabolism. The problem there, again, is contamination, because if we have a lot of glues or adhesives, for example, on that timber that are made from fossil fuels or other kind of chemical resources, that compostation or the decomposition of that product doesn't work. We're not allowed to kind of return it into that biological metabolism. And so that is one of the reasons why the circular economy asks for that strict separation of technical and biological nutrients, so that we can keep these big metabolisms running at their highest level and utility.
So tell us a little bit more about, as you've dived further into it, which parts of the ecosystem naturally lend themselves and which are sort of resistant to the circular economy idea, or in terms of recycling in the construction industry?
The construction industry is a very curious structure, because for every building we have a multitude of actors that are involved in every decision, and then we have a very global construction industry right now. Materials come from all over the place, and so supply chains, for example, are extremely difficult to then kind of convene on this one spot at the right moment, the right time. And to really shift the paradigm, all of these actors need to be involved in that shift. And so that involves time, unfortunately, but it also involves a lot of education, motivation, and the willpower of all of these actors to be on board in that shift. And I can maybe give you an example of a building that we built in Switzerland in 2018, where we sort of changed the way a normal construction site, or actually a normal design process, is operated, and we brought all the kind of decision makers, all the stakeholders into the same room in the very beginning, in the design stage, where we just had a sketch of how this building could potentially look like. And I'm usually using that the kind of planner for the sprinkler system as an example. So he also was sitting through a year of design meetings, which is something he never did, and usually would never do. And in many cases, you can't afford it. This was a research project, and so we fortunately had the budget to allow for that. But the interesting thing about it is that by the time we had that building fully designed and we then needed a sprinkler system, the company provided a solution that was fully circular that we had and could have never thought about, right? So that kind of process of like working through every detail for a year led to new solutions that and new solutions that came from the person that in the end is actually building it, that has all that intrinsic knowledge about that specific aspect of a building. And so there really the role of the architect was that kind of motivator, negotiator, and kind of setting the overall goals where that building should go. But the important knowledge about how to then apply the solution or find a solution came from these initial actors. And that really shifted that building to a completely different and a very circular solution in the end. And so, yes, collaboration is key, and we need to talk much earlier. That's sort of my message, right? We need to bring everyone on board much earlier, and we need to all realize that that it is time to do this now, or actually it should have been done yesterday. But since we can't go back in time, we need to start acting today.
Just out of curiosity, what was the solution in the sprinkler system that made it circular? If you could share that.
I can share that. It's essentially nothing really new. It's a combination of kind of new materials but old techniques. So one of the key problem was that pipes are being clamped together in a way that they cannot be separated, and so we just went back to screw connections, which isn't really an invention, right? Because we used to do this 10 years ago, 20 years ago, 30 years ago. But by combining new materials with kind of traditional connection details, we found a way to really provide a completely circular solution. The benefit was that this really came from the company, and they proposed how to do this, and they of course had then the technology and the equipment to do that. And so the implementation was a very, very seamless process that way, and really helped. And it's just one of the examples. I think we had many examples like that along the way, where stakeholders brought their own new solutions to the problem. How do we solve something in a circular way?
Right, it's just a different way of thinking, right? Instead of demolition at the end of life, you're thinking deconstruction, maybe?
The other point is that we really don't need to reinvent the wheel. I mean, for centuries, if not not thousands of years, right? We've built circular buildings. We sort of lost much of that knowledge, or maybe we didn't lose it, but we stopped applying much of that knowledge in the last 60, 70 years, when optimization was not on materials and their circularity, but on performance and speed and time of production. And so the priorities shifted, and now it's time to shift those priorities once more to make sure that within all that productivity and within all that industrialization of the industry, because that is equally important, we find ways to retain the quality of materials.
And that's perfect segue, because you did talk about the fact that you had the money, or you had the research grant to get all the stakeholders in the room and work with them for a year to redesign. I guess the key question here is profitability. How do you ensure that this becomes, the mainstream idea, if you take into account profitability and longevity for this design principle?
Well, if you look at what's happening right now, we have a major supply chain disruption. We have prices that are skyrocketing. We have an inflation, and that is very, very, very problematic for current construction. I know many buildings that were halted because construction prices doubled. So we have a situation right now that really makes us rethink material supply chains. And the circular economy is one that can actually help with that solution, right? Once we start activating what is right next to us as a resource, we suddenly have a whole new stock of materials that we can access. And in many cases right now, there is a kind of stigma about this resource, which is, if you look at it from a scientific point, in many cases, not true. One example being wood that comes from a deconstructed building, right? The stigma is, well, we can't reuse timber structurally because who knows, right? But in many cases, that timber is actually of a higher quality than what we would buy right now, because that tree grew 100 years ago. It grew much slower. It was cut much later. The growth rings are much, much tighter. The structural strength of that timber is impeccable. The tree was rested for 100 years in a dry climate, right, indoors behind an installation. It's straight. It doesn't warp the moment you put it into a construction site, because it then is suddenly in humidity and other things. And so there is a wonderful resource available, and we're losing that resource by pushing buildings into landfills, which is unfortunately common practice right now, because we don't see that value. And it's so much of it is, we have the technology, but much of it is just a shift in perception. And the current situation actually helps us from a business case perspective, right? Because of these shifting prices across the market.
That is fascinating, what you just told me about timber, because I was not aware of that. I thought that material integrity would sort of degrade. That is fascinating. So are there like tests available that would give the consumer that satisfaction that what I'm getting is actually of higher quality and maybe could be priced even higher?
This goes into the conversation about certification and policy making, which is, I think, another really important aspect. And only if we work on that in kind of parallel to all the other things that the design aspect and the kind of deconstruction question, I think we're going to be successful. Interestingly, also there, if we talk about timber again, there's a shift in the US now. We have 3 states that loosened the requirement of a recertification for timber to use it as a structural material. Those are 3 states that have historically very high quality old growth timber. And so these states realized how great that quality is of material that can be harvested from buildings that were built 100, 200 years ago. And so in these cases, we now can directly reuse the material for new structures. If that is not the case, in many cases, a visual inspection is enough to make sure that, yes, this isn't cracked, right? Or it's in many cases, it's pretty simple to establish the quality of that material. It's just a step that needs to be done. From a building code perspective, actually, it doesn't really matter if you use virgin or secondary resources, as long as you fulfill basically the code requirements on what that material needs to do, right? So if you can certify that a material fulfills the norm, then you can use that according to the code. I can give you an example from a building that we built in Germany in 2019, where the whole structure is made out of reused steel. And we took that steel from a former coal-fired power plant, which was decommissioned. It's a sort of anecdotal story in Germany. We're decommissioning all of our coal-fired power plants right now because of environmental reasons. But then we're stuck with huge infrastructure buildings that no one knows what to do with. And unfortunately, many of these buildings are simply blown up right now. And so we were able to go into one of those and basically cut out the steel beams that we needed for a new structure before that power plant was then demolished afterwards. The problem with that was we had no idea what steel that was, what kind, what type, because there was no documentation available. And so we needed to do 5 tests in a pretty high sample set on all of these steel members, which is a kind of chemical analysis, notch test, tensile test, compression test, weldability, to check what did we actually harvest. The result of that was it's standard structural steel. and as you would get if you go into a shop now and order steel beams. And that knowledge then, with that knowledge, the building permit process was no problem anymore, right? Because then we could just use the normal process. And so that recertification essentially guaranteed that afterwards you're part of the current process again, right? You don't have to reinvent that part of the process. That's already set up. But it leads me to a really important side aspect of the circular economy, and that's this documentation that is missing, right? So if we now implement material passports and have a continuous documentation of all the materials that are in the built environment, then we can save at the end on the cost of the recertification, because we can just say, well, the material passport says this is this type of steel. It was implemented 50 years ago, and in the last 50 years, it was repainted twice at these and these dates. It was once in an earthquake, but it wasn't too much to kind of change the integrity of the steel beam. And so, yes, now we can just reuse that steel directly without having to recertify it. And that is super important, because the recertification right now is one of the cost drivers that limits the ability.
Right. And if you think about the resource requirement for actually taking the material out of a existing building, is that a big hurdle in your mind?
We just did a deconstruction project in January where we the site essentially had 11 buildings from 1906 on it. Mm-hmm. And they all were cleared to make space for new student housing. And we were able to essentially side by side deconstruct and demolish two of these houses, which is a super interesting case study because they were basically they were very similar in their make. They came from the same year. They had more or less the same size. And so the study really looked at the kind of differences between deconstruction and demolition. One of the requirements from the developer was that we don't take 6-7 weeks for the deconstruction, but the deconstruction needed to be as timely as demolition, which is one of the key problems in this conversation usually, because it says, well, we don't have the time to deconstruct. Mm-hmm. And so what we did in the end is we brought in experts that from across the nation, and as a kind of big academic team as a big team of academics and industry partners, we did a panelized deconstruction, which means you're essentially cutting the house into as big parts as possible, meaning something like 8 by 10, 8 by 12 feet, something that still fits on a flatbed that can drive without any problems on the road. And so you're cutting whole gable walls, whole roof panels, whole walls out of that building and put them on the flatbed and drive them off into a warehouse. And then the post-processing happens in the warehouse. Okay. Under controlled conditions, right? So you have a kind of, you can work in the rain because you have a roof on top of you. You can work in the winter. So it's about the kind of social aspects of that kind of workforce development as well. But more importantly, you have full control over the materials. You can have full control of the process that is set up. And we were out of that site in 5 days. So we demolished, we deconstructed, a 4,500 square foot house in 5 days. So that then the developer could come in and start redeveloping that site quite quickly. And so that is not an argument. The time component is not an argument. Now, when we talk about the money and the cost of this, naturally, we have a higher cost, labor cost in deconstruction than in demolition. But this is a big question on perspective, right? And who looks at this? Because the advantage is that you have 6 jobs over 1 job in a deconstruction project. We're bringing people into labor, and we're creating new local jobs. We're creating green jobs, which is something that is from a community and from a municipal perspective is super interesting. The next aspect is that what are we actually pricing? Do we in a current demolition project, we're only pricing the cost to get rid of the materials, but we're not pricing the societal cost that is attached to it. We're not paying for the landfill. We're not paying for the contaminants that seep out of the landfill and go into the water and then contaminate drinking water. We're not talking about air pollution. Deconstruction project, if it's not done well, causes quite a bit of air pollution, and the neighboring houses suffer from that. The question is, where does demolition happen most of the time? So we also have a kind of equity and societal question that comes with it. And so if we were to price demolition accordingly to the damage that it's doing to the planet and society, deconstruction is the better option.
What you described was a building more in the North America or the West Side, where it's built out of wood, or primarily wood, but in other parts of the world, concrete and cement is used. Do you have any perspective on how the same circularity argument or processes can be used there?
Yeah, thanks for bringing that up. Naturally, the example that I described is very local and very unique to the area that we're in here. But the thought process is applicable in all other contexts as well. It just takes a kind of rethinking and adapting to the specific context and the specific material palette that we're dealing with. We just had an architect speak at a lecture series here the other day from Basel in Switzerland. And Basel did something super interesting. They started cataloging their municipal and public buildings in a material inventory. And so a parking garage out of concrete, right, essentially turns into, we have this and this many panels. They could be deconstructed this and this way. We have columns that you can cut out, etc. And so now in their kind of public tender projects and competitions for new buildings, that material inventory becomes part of the process, and teams are encouraged to use these elements from that inventory in their designs, and that leads to benefits in terms of who wins that competition. This is super forward thinking, right? But it essentially allows us to already in the design phase of a project close the loop before we even start deconstructing a building. And so depending on the size, for example, that this new building would need, we can then go in and say, let's cut that parking garage into exactly those pieces, reduce kind of the time in post-processing, right? Because we don't cut any piece just to get rid of it from site as quickly as possible and then have to readjust it again. But we can already design the deconstruction process so that we essentially have elements that then can go directly just in time to the new construction site. And so closing that connection between demand and supply already this early in the design process will help answer exactly that question. And yes, they are doing this with concrete, right? So they're cutting concrete panels that are then reused as concrete panels, which is the best way we can essentially reuse concrete, because of course we can grind it down into aggregate and then make recycling concrete out of it. But that solves the resource problem of concrete, but it doesn't solve the embodied carbon problem of concrete, because that comes from the cement, and the cement emits, as we all know, 8% of global CO2 emissions come from just the curing and the production of cement. And so switching out the aggregate doesn't change anything in that conversation. Versus reusing concrete as a structural element, it will dramatically change that part of the conversation.
This is really interesting, because when I was thinking deconstruct, I was sort of automatically going down to the element. And what you've talked about is taking, construction elements. So maybe, a panel, a window, instead of just thinking of it as glass, think of it as already, parts of a building that maybe are amenable to being reused.
Definitely, we're shifting more and more to a conversation about components, to actually address both the question of labor, like how much labor needs to go into this to become a valuable, sellable or resellable product again, and the amount of time that is involved in it, which is essentially also cost, right? And the amount of resources that go into the post-processing of this. And so this shift, I think, is important, but it only works if the design world and the policy world kind of goes hand in hand with that shift. And so this is something that I think needs to happen as well, and is happening. I mean, just yesterday, the city of San Antonio, for example, the Common Council in San Antonio approved their deconstruction ordinance. So there's super interesting political things happening as well right now in the US.
Fascinating. There are different models of monetization that can be applied to different things. So you mentioned rentals or maybe subscription and other things. So what have you experimented with, or have you seen people experimenting with?
Yeah, I think you sort of put out the catalog already. We can, of course, simply in quotation marks, take a material and kind of post-process that and sell it as a material again. We can, that's sort of the most common way, I think, in reuse. We can then go to a kind of component level and use those as components. And then we can kind of look at different models that think about how can we make a business model out of the fact that a material will return. And I think a good example is actually the carpet industry, because once a company developed a new carpet tile that is 100% recyclable, and this happened, I think 2 or 3 companies recently made that shift, right? Where you then have a recyclable yarn, you have a recyclable backing, you can separate the backing from the yarn, etc. And so suddenly that tile turns into a resource, right? It's especially for the company that produced it, because they know what material is in there and they know how to handle that material. And so the ideal scenario is that that tile, after it's being used, returns to the company and is then just fed back into the process and turns into a new tile and then returns to the factory. Now, the question that this company now asked themselves is, how can we take out the insecurity in that ideal loop that the end user puts that product into the dumpster? And all the ingenuity, all the quality, all the development that the company put into the making of that product is lost because of the fact that it wasn't treated according to that kind of drawn up scenario, right? And so the shift in business model essentially is not just a new way of monetizing this product, but it is also a way to ensure that the product returns. So that the shift to a leasing model in this case says, well, you pay every month a certain amount for the service that the carpet gives you, right? You can walk on it, it's nice, it's soft, it's colorful, etc., etc. So you pay for the service and not for the product anymore. And by the time you don't want that service anymore, you then return the product to the company because it's not yours, right? You just leased it. And so the company also has the knowledge in advance that, for example, in 8 years, this amount of carpet will return. And so they can plan with that in advance and become less dependent on volatile resource markets, where you never know what happens with this and this resource, how much is it going to cost tomorrow, right? Because they know, well, we have that stock. It's just not in our warehouse. It's distributed across the built environment.
And that makes a lot of sense. But who pays for, return of that material? Because I think if we look at some of the other industries and recycling done there, the hardest part is getting the material in a reusable condition, getting it back to the recycling facility, and then who pays for that cost? Give us your thoughts on that aspect.
One of the key problems in implementing this on a larger scale is exactly the logistics. Also in the carpet industry, especially in our global supply chains, and because it's one thing to make sure that within the US or within California or within Denmark or the Netherlands, right, within this kind of smaller jurisdictions, you have a kind of take-back system that overcomes the difficulties of this return logistic. But the moment you then ship these products to 52 countries, right, or something like that, and in 48 of these countries, you don't have this kind of return systems, then it becomes really difficult. And so I don't have a solution either yet to this. It's just we're aware of it. And I guess the question is, how does a company want to set up their own distribution system? Right? Is there a way to kind of work together? Maybe, I mean, much of the circular economy is about collaboration as well. We're not going to shift the system alone. So are there ways to kind of organize these transfers better, as we have been optimizing the linear economy in the shipping industry for the last 50, 60 years very effectively? So maybe as a society, we find a solution to that as well.
And meanwhile, there could be localized solutions, right? So, transporting material locally might be less expensive. I'm just theorizing. I don't know the answer either.
No, that's true. And it goes back to my earlier comment, the smaller the cycle, the better. And that is always true. So if we are able to move a carpet tile from in kind of industry development where we just did a retrofit of a new shop front, right, to a residential unit just across the street, that is the best case scenario. And anything above that creates carbon emissions, right? Every mile more is essentially emissions, as long as we don't also shift to a fully carbon-free transport system, which is also part of that goal, of course, right? I mean, we all know that every cycle always needs a little bit of input to kind of kickstart again. We don't have a perpetuum mobile yet, so nothing circles endlessly for free. And so that energy input that we bring into the circular economy needs to be from regenerative sources as well.
So Felix, this has been fascinating. Have I not asked something that you wish I had asked?
There's so much to say. I mean, it's a fascinating field, and I think what motivates me in the morning is that there is so much momentum right now. I think it's fascinating to be a small part of that movement, especially in the US, where we're shifting policy, we're shifting the making of products, the design of products. And especially the architecture and construction industry is in a very, very interesting moment right now, where we start demanding that shift, both from the architecture side, from the client side, from the producer side, and every day something new happens, right? Every day a new study comes out that supports that movement, and so I'm actually quite optimistic right now. I think that's maybe a good way to phrase and summarize this.
Well, that's a great wrap up. Thank you so much for your time today, and look forward to seeing what you come up with next.
Thank you so much. Thank you for inviting me.
The Decoding Innovation podcast series is a limited production of the EY Nottingham Spurk Innovation Hub, based in Cleveland, Ohio. For more information, visit our website at ey.com/decodinginnovation. If you enjoyed this podcast, please subscribe, leave a review wherever you get your podcasts, and be sure to spread the word.